Welcome to the DIY Honda Garage channel. The DTC B1280 indicates a malfunction in the turn signal switch circuit of the 2006 to 2011 Honda Civic. This diagnostic trouble code is generated when the system detects an issue with the operation of the turn signal switch, which is critical for activating the turn signal lights. Located on the instrument panel, the turn signal switch is easily accessible for inspection and testing. This system plays a crucial role in vehicle safety by signaling intended turns or lane changes to other drivers. When the turn signal switch circuit malfunctions, it may compromise the reliability of the signaling system and pose safety risks on the road. Therefore, identifying and rectifying the underlying issues is essential for maintaining vehicle integrity and ensuring proper function. The DTC B1280 signifies a malfunction in the turn signal switch circuit. The affected component is the turn signal switch, integral for controlling the vehicle's turn and lane change signals. It is positioned on the steering column or instrument panel for easy access during operation. This switch, when activated, completes the circuit to illuminate the relevant turn signal lights. Its proper functionality is essential, not just for driver communication, but also for enhancing safety by alerting surrounding vehicles. If this switch fails, it results in potential miscommunication or hazards on the roadway, thus requiring prompt diagnosis and repair. There are several potential causes for the DTC B1280. Firstly, a faulty turn signal switch could send incorrect signals or fail to function altogether, causing the circuit malfunction. Secondly, poor electrical connections, such as corrosion or looseness in connectors or wiring, can disrupt the reliable operation of the switch. This is crucial because a stable electrical connection is necessary for the signals to relay properly. Additionally, the Motor Integrated Control Unit, MICU, which manages the turn signals, may have internal faults impacting the circuit. Identifying these causes is essential for effective troubleshooting and ensuring that the signaling system operates as intended. Drivers may experience several symptoms if DTC B1280 is present. One major symptom is that the turn signals may not function at all, which poses a significant safety hazard. In some cases, the signals might operate inconsistently, turning on or off unexpectedly, or lighting up without user input. Additionally, warning lights on the dashboard could illuminate, providing further indication of a malfunctioning system. Each of these symptoms can detract from overall vehicle reliability while also increasing risks during driving. As such, prompt recognition and diagnosis are crucial for maintaining safe operational standards. The first troubleshooting step for DTC B1280 involves clearing the diagnostic trouble codes using the Honda Diagnostics System, HDS. The HDS is an advanced tool specifically designed for Honda vehicles, providing comprehensive diagnostic capabilities. By clearing the DTCs, you reset the vehicle's computer systems to remove any previously logged codes that may not reflect current vehicle conditions. This is a vital step as intermittent faults can sometimes cause codes to appear erroneously. After clearing, it allows for a fresh assessment of the turn signal function. Ensure to follow up with subsequent steps to confirm whether the issue persists. In the second step, ensure the ignition switch is turned to the lock 0 position and then back to the on 2 position. This sequence helps reset the vehicle's electronic systems, allowing for accurate readings during diagnostics. Operating the ignition switch this way prepares the vehicle for checking the turn signal switch's functionality. It's essential to give the system a moment to stabilize after this sequence before proceeding to the next steps in the diagnostic process. Ignition system resets can help clear temporary faults that might interfere with operational checks. The third step involves operating the turn signal switch in both left and right positions after performing the ignition switch sequence. It is crucial to hold the switch in each position for approximately 6 seconds to allow the vehicle systems to register and respond to the switch's actions. This operation tests the responsiveness of the turn signal circuit while providing the system an opportunity to detect and log any new issues that may arise during switch usage. After testing in both directions, allow the vehicle's diagnostics to reflect any changes in operational status before proceeding to check for existing DTCs again. In this step, return to the Honda diagnostic system to check for any recorded DTCs. Assessing the retrieved DTC status will inform you whether the B1280 code is still present after performing the previous steps. If the DTC B1280 is indicated again, it suggests that the issue remains unresolved. Conversely, if the code does not appear, it may indicate an intermittent failure, suggesting that the system is functioning correctly at that moment. However, you should still investigate potential causes like loose or poor connections, as intermittent issues can commonly signal underlying problems that need addressing. Step 5 involves selecting the lighting option from the Body Electrical System Select menu in the HDS. From here, you will enter the data list to monitor the values pertaining to the turn signal switch. This data provides crucial insights into whether the turn signal switch is functioning within the expected parameters. Evaluating the data list allows you to see if the switch delivers outputs that match its position. On for left when switched to left. On for right when switched to right. Confirming the data correctness in these switching states serves as an essential diagnostic check before proceeding to any corrective actions. In this step, you will check the data list values when the turn signal switch is in both left and right positions. Specifically, when activated to the left, the expected readings should show left on and right off, and vice versa when the switch is engaged to the right. If both values are correct, indicating proper operation, it suggests that the MyQ may be at fault and may require replacement. However, if not all readings are accurate, the troubleshooting advances to the next step for further investigation. This thorough value check ensures each component is functioning correctly before isolating further faults. In this step, turn the ignition switch back to the lock 0 position, which is essential to ensure safety and prevent any electrical short circuits while working on the vehicle. Once it's locked, disconnect the combination light switch, specifically the 12P connector, to isolate the switch from the system for accurate testing. This action helps eliminate potential interference from additional components, allowing for the focused assessment of the turn signal switch function. By disconnecting, you can evaluate whether the circuit issue persists or is localized to this specific component, thereby streamlining the diagnostic process. After disconnecting the combination light switch 12P connector, the next step involves turning the ignition switch back to the on second position. This allows power to flow to the electrical systems, which will be necessary for the next round of diagnostics. Again, navigate to the lighting section of the Body Electrical System Select menu on the HDS. This step is crucial for checking the signal outputs in the system once more, now that the potential contributions of the combination switch have been removed. Such focused testing helps clarify whether the prior issues were switch-related or stemmed from other components. In this step, you will again check the data list and assess the values of the turn signal switch after having disconnected the combination light switch. Like before, you will observe whether the switch outputs on the data list reflect the appropriate readings. Left on when the switch is in the left position, and right on when engaged to the right. If both outputs display off, it indicates that the previously identified switch or connection issue is no longer contributing to the circuit fault. However, if the outputs do not reflect off, further isolating and testing must occur to identify the root cause of persistent issues before proceeding to the next step. At this point, if both data list values show off when the turn signal switch is in either position, it suggests that the previously identified issues may have been resolved through the steps taken thus far. If this is the case, you would proceed to step 15 for potential corrective action. However, if the values indicate otherwise, signaling that the switch is still sending improper signals or has not rectified itself from prior issues, then you must proceed to step 12 for further examination. This decision-making process ensures that all potential faults are thoroughly investigated to restore the functionality of the turn signal system. Upon completing repairs related to DTC B1280, it is essential to verify the integrity of the work. Full functionality of the turn signal system must be confirmed by testing all modes of operation. Engage the turn signal switch to the left and right positions, ensuring that each side illuminates correctly without faults. Additionally, check for correct feedback on the dashboard indicators, verifying that the signals correspond accurately to the user's input. This verification step ensures that the repairs made have successfully resolved the issues, while also assessing system resiliency. Successful testing indicates that the turn signal switch circuit is now functioning as designed, and further assures the owner's safety on the road. Preventive maintenance plays a vital role in the long-term functionality of the turn signal switch circuit in a Honda Civic. Regular inspections of electrical connections can help identify signs of wear, corrosion, or looseness before they escalate into malfunction issues. It is equally important to keep connectors clean and tightly secured, as dirt or loose connections can disrupt the circuit flow. Routine checks can prevent intermittent issues from occurring and prolong the lifespan of vehicle safety systems. Additionally, maintaining an organized approach to electrical system management fosters a more efficient troubleshooting process when issues arise. Standardizing these practices will promote reliability and mitigate the risk of future DTC occurrences. In summary, DTC B1280 highlights a malfunction within the turn signal switch circuit for the Honda Civic models from 2006 to 2011. This repair procedure emphasizes the importance of a methodical approach to troubleshooting by following specific diagnostic steps. Regular maintenance and inspection can significantly enhance reliability and mitigate potential issues. Awareness of how each component interacts within the electrical system is crucial for achieving successful repairs. As with any troubleshooting process, the goal is to ensure the safety and functionality of the vehicle for all drivers and occupants. By systematically addressing the issues and taking preventive measures, you can help maintain a reliable vehicle signaling system. Please like and subscribe to the channel. See you next time.